Okay, I'm going to discuss the Homework 8 logic circuit simulator assignment. I'm using a simulator written by David Eck from William and Hobart Smith Colleges. It's called Eck's Logic Circuits, as you can see. It's from his book, The Most Complex Machine. You're going to write something that looks similar to this. You're going to write a program that when we run it, animation displays a window like this. You'll display a NOT gate, an OR gate, and an AND gate. You'll also have an input and an output. So everything on the left, you won't need these little red things here, so don't worry about them. But you do have to label these. These are not going to be images, but you're actually going to draw them. That's a triangle, like a little polygon, and that's a circle. You can do this also as a polygon. Anything that looks close to this is fine. And this one actually is made as a polygon as well. But anything you can do that makes an OR gate look OR gate-ish and an AND gate look AND gate-ish is fine, as long as we can tell the difference. In any case, you're also going to need clear, load, and save. And those are going to have to be buttons, but not like actual buttons. They're just going to be words that you draw inside rectangles, and if the user clicks on them, they'll act like a button. Okay, so the one thing that you're not, and then down here you're not going to do these things. You're not going to have power, you're not going to have delete, you're not going to have undo or iconify or enlarge, and you're also not going to have title here or fast. Okay, so here's the deal. I have to be able to select an input and place it here. Now I did a drag and drop. You're not going to do that. Instead, I will select the thing I'm going to select, such as an input, and then when you click, you get one of those. So it's only on mouse presses. Press to select the type, press to see where it's going. Okay. Then I'll take, say, like another input, put it out here, and output out here, and then for now I'll just drop one AND gate out there, and again, no drag and drop. So now if I want to connect this input to this gate, I would click here and then click there. Now in the program I'm using, I would drag, but in yours, again, no drag. Click, click there, they connect. And the second one doesn't have to, all you have to do is click anywhere over the first item, and then click anywhere at all over the bounding box of the second item. And you might even make it a little bit wider than the bounding box. So if you get near it, it still hits. So click here, connect. And now the next thing is, you have to be able to turn the power on and off. I actually lied about that, because when the power is off, when I can click in a input, I can connect it to things. When the power is on in your implementation, when I click in an input, that just turns it on. So now when there is power, power is represented by red. When there isn't, it's represented by black. Red, power, red, power. Since this is an AND gate, when there's power to both of them, there's power to the output. And you can see that the output is lit here. I could save this, and you don't need to save as dialog. You can save it to any file you want. And I can clear, you need to have clear. And I can load back, and now you'll load from the file you saved it to. And interestingly, it actually failed, which is pretty funny. We just uncovered a bug in Eck's logic circuits. You can't have such a bug. When you say load, it's going to have to load the circuit that you saved. In any case, oh, and then what the format of that file looks like is totally up to you. And if you can't get load and save to work, you'll still get most of the points. Load and save will probably be worth, say, 5 to 10 points of the total project. So now let's do another one. Let's look at what an XOR looks like. For that, I would take put an input here, and I'll put an input here, and I'll put an output over here. And in XOR, you take an AND of it's A and not of B, XORed against the AND of B and not of A, and then you have to OR these together. Now if I got that right, then once I turn the power on, it's false XOR false is false. 0 XOR 0 is 0. 1 XOR 0 is 1. That worked. 0 XOR 1 is also 1, and 1 XOR 1 is 0. So yours basically has to work like this. We'll grade liberally on the graphical portion of this. The correctness part, certainly when you hook this up, it had better act like XOR. We're also separately going to have an auto-gradable part because we're going to give you some non-graphical test code that's going to test your gate class, and that test code has to, of course, pass. The autograder can run that. Your graphical part should be below the ignore rest line, and human graders will grade the portion that looks like this. That's it. Have fun.